In question 1, I will start the proof by assuming that there exists a number n such that if n cubed is even, then n is odd. Now let n be an odd number, so n can be written in the form 2k plus 1, where k is an integer. So n cubed is equal to 2k plus 1 cubed. I can expand this either by using the binomial expansion or by writing the same bracket 3 times and expanding. Then I will take out a common factor of 2 from the first 3 terms and conclude that n cubed is an odd number, since I can write this in the form 2 times something plus 1. So this creates a contradiction with my original assumption. So I can finish off with a conclusion now by rewriting what the question originally asks for. In part A, I will start by taking out a common factor of 4. So 4 minus 5x to the minus a half equals 4 to the minus a half, 1 minus 5 over 4x to the minus a half. This is equal to 1 over 2, 1 plus minus a half times minus 5 over 4x plus minus a half times minus 3 over 2 over 2 factorial times minus 5 over 4x to the power of 2. This simplifies to 1 over 2, 1 plus 5 over 8x plus 75 over 128x squared. And if I expand the brackets, I will get 1 over 2 plus 5 over 16x plus 75 over 256x squared. In part B, I have 2 plus kx over the square root of 4 minus 5x. This is equal to 2 plus kx times 4 minus 5x to the minus a half. Now the second bracket is what I have expanded in part A. So 2 plus kx times 1 over 2 plus 5 over 16x plus 75 over 256x squared. Now I need the coefficients of x and x squared. The coefficient of x comes out from the multiplication of kx times a half, or 2 times 5 over 16x. And for x squared, I need these combinations. Now, if you're not sure, you can expand the whole thing. In this case, I will have 1 plus 5 over 8x plus 75 over 128x squared plus 1 over 2 kx plus 5k over 16x squared plus other terms with higher powers. I can group the coefficients together. So I've got 1 plus 5 over 8 plus a half k for x plus 75 over 128 plus 5k over 16 x squared. So now I can compare coefficients. 5 over 8 plus a half k equals to 3 over 10, which gives me k equals minus 13 over 20. And for part C, 75 over 128 plus 5k over 16 equals to m. I can use the value of k from above. M comes out to be 49 over 128. In question 3, before finding the volume of revolution, I will need to find out where the graph cuts the x-axis. So I will start by setting e to the 0.5x minus 2 equals to 0. So e to the 0.5x equals 2. 0.5x equals to ln 2, and x equals to 2 ln 2, which is equal to ln 2 squared, which is ln 4. So the volume of revolution is pi integral of y squared dx with limits 0 ln 4. This is equal to pi integral of e to the 0.5x minus 2 squared, same limits. I will expand this, e to the x minus 4e to the 0.5x plus 4 dx, same limits. And now I will integrate, this is e to the x minus 4e to the 0.5x over 0.5 plus 4x with the pi at the front and the required limits. So now I will substitute my limits. This gives me pi e to the ln 4 minus 8 e to the 0.5 ln 4 plus 4 ln 4 minus e to the 0 minus 4e to the 0 over 0.5 plus 0. Now note this here, 0.5 ln 4 is equal to ln 4 to the 0.5, which is equal to ln 2. So I get pi times e to the ln 4 is 4 minus 8 times e to the ln 2 is 2 plus 4 ln 4 minus 1 minus 8. Now note again that 4 ln 4 is equal to 4 ln 2 squared, which is equal to 8 ln 2. I'm converting this into ln 2 because this is what the question wants. So now I have pi 8 ln 2 minus 5, and if I expand this I get 8 pi ln 2 minus 5 pi, which is in the form required. I will start part A of question 4 by setting y is equal to 0. This means that 0 is equal to t to the power of 3 minus 4t. I will factorize, so t squared minus 4. Know that the bracket is the difference of two squares, so 0 equals to t minus 2, t plus 2. So t is equal to 0, or t is equal to 2, or t is equal to minus 2. Each one of these will give an x value. For the first one, x is 0. For the next one, x is minus 4. For the last one, x is 20. Since a has a negative x value, a must be minus 4, 0. Hence, b is 20, 0. For part B, I will need to find dy dx. First, I'll find dy dt, which is 3t squared minus 4, and then dx dt is equal to 4t minus 6. Hence, dy dx equals 3t squared minus 4 over 4t minus 6 at t equals minus 2, that's the t value at point B, dy dx equals minus 4 over 7, and that is the gradient of my line, so y minus 0 equals to minus 4 over 7 x minus 20. I will multiply both sides by 7. 7y equals to minus 4x plus 80. And then I'll take everything to the left. So 7y plus 4x minus 80 is equal to 0. In part C, I will solve the equation of the tangent together with the two parametric equations simultaneously. I will substitute the parametric equations into the equation of the tangent. So I will have 7t to the power of 3 minus 4t plus 4, 2t squared minus 6t minus 80 is equal to 0. If I expand and simplify this, I will get 7t to the power of 3 plus 8t squared minus 52t minus 80 is equal to 0. Now, I know there's a tangent at t equals minus 2, so there is a double root of this equation at t equals minus 2, which means that t plus 2 squared is a factor of this equation. So I can proceed with the long division to find the third factor. T squared in 7t to the power of 3 goes 7t times. So I've got 7t to the power of 3 plus 28t squared plus 28t. I will subtract and I will get minus 20t squared minus 80t minus 80, and then t squared into minus 20t goes minus 20 times, so I've got minus 20t squared minus 80t minus 80, 0 as a remainder. So if I factorize my cubic equation, I will get t plus 2 to the power of 2 times 7t minus 20 is equal to 0. So the missing t value is 20 over 7. And if I substitute this into the x equation, it will give me minus 40 over 49. In part A of question 5, to integrate this expression, I will bring the 1 over x squared to the numerator and make it x to the power of minus 2. To integrate this, I will use integration by parts. I like using a table. My u is ln x and my v dash is x to the minus 2 or 1 over x squared. If I differentiate u, I will get 1 over x or x to the minus 1. If I integrate v dash, I will get x to the minus 1 over minus 1, which is equivalent to minus 1 over x. So the integral becomes minus 1 over x ln x minus the integral of minus, so I've got minus minus equals plus, of x to the minus 2 dx. So this one will give me minus 1 over x ln x plus x to the minus 1 over minus 1 plus c. I can simplify this one to minus 1 over x ln x minus 1 over x plus c. For part B, I need to integrate 3x to the minus 2 plus 2 over x plus ln x over x squared dx. I have split my fraction into 3 individual fractions, And in this case, I've got limits between 2 and 4. So the integral becomes 3x to the minus 1 over minus 1 plus 2 ln x. And then I have my result from part A, which is minus 1 over x ln x minus 1 over x between 2 and 4. Now I can group together the first and the last, and also the second and the third. So this simplifies to minus 4 over x plus 2 minus 1 over x ln x, again with the limits 2 to 4. So if I substitute my limits, I get minus 4 over 4 plus 7 over 4 ln 4 minus 4 over 2 plus 3 over 2 ln 2. Note that I can write ln 4 as ln 2 to the power of 2, which is 2 ln 2. So this result simplifies to minus 1 plus 7 over 2 ln 2 plus 2 minus 3 over 2 ln 2. So my final answer is 1 plus 2 ln 2. In part A of question 6, I'll start by taking logs of both sides. So ln y equals to ln of x to the power of sine x. I will use the power law to bring down the power. So ln y equals to sine x times ln x. And then I will do implicit differentiation. So 1 over y dy dx equals to sine x over x plus cos x times ln x. I am using the product rule on the right hand side. So dy dx is equal to y sine x over x plus y cos x times ln x. Then in part B, I will set dy dx equals to 0. So y brackets, I'm going to factorize dy out. Sine x over x plus cos x times ln x is equal to 0. So either y is equal to 0, which I will reject because y is positive, or sine x over x plus cos x times ln x is equal to 0. I will multiply everything by x. So sine x plus x cos x ln x is 0. And I will divide everything with cos x. So sine x over cos x plus x ln x is equal to 0. And this will give me the final answer, which is tan x plus x ln x equals to 0. In part I have an option. I can use u equals the square root of 2x minus 1, or I can use u equals to 2x minus 1 without the square root. I will proceed with this method. Then u squared is equal to 2x minus 1. I will use implicit differentiation. So 2u du dx equals to 2. I can cancel out the 2's. So I'll be left with u du is equal to dx. I will change the limits as well. X equals to 5 implies that u is equal to 3. And when x is 1, this will give me a u value of 1. So the integral of 3x over square root of 2x minus 1 dx from 1 to 5 will be equal to the integral of 3 times u squared plus 1 over 2 all over u times u du from 1 to 3. I can cancel out the u's, so I will get the integral of 3 over 2 u squared plus 3 over 2 du from 1 to 3. This will give me 1 over 2 u to the power of 3 plus 3 over 2 u limits 1 and 3. If I do the substitution, I will get 27 over 2 plus 9 over 2 minus 1 over 2 plus 3 over 2, and this will give me 16. In part II, I will split this into partial fractions, but first I will do long division. 6x squared plus 0x minus 16 divided by 2x squared minus x minus 3 goes 3 times, and I will get 6x squared minus 3x minus 9. I will subtract, and I will get 3x minus 7. Now, this 3x minus 7 over x plus 1, 2x minus 3, I will write it as two fractions, a over x plus 1 plus b over 2x minus 3. This will give me 3x minus 7 equals to a times 2x minus 3 plus b times x plus 1. Now, if x is equal to minus 1, this will give me minus 10 equals to minus 5a. So a is 2. And if x is 3 over 2, I will get minus 5 over 2 equals to 5 over 2b. So b is equal to minus 1. So I have the integral of 3 plus 2 over x plus 1 minus 1 over 2x minus 3 dx, and this will give me 3x plus 2 ln of x plus 1 minus 1 over 2 ln of 2x minus 3 plus c. For part A of question 8, I will start by writing three equations, one for each component of the two lines. So 4 plus 3 lambda equals 2 plus 2 mu minus 3 minus 2 lambda equals to 0 minus mu, and 2 minus lambda equals to minus 9 minus 3 mu. I will label these as 1, 2, and 3. From 2, I can get mu equals to 2 lambda plus 3. And then I will substitute this into equation 1. So I will get 4 plus 3 lambda equals to 2 plus 2 times 2 lambda plus 3. This will give me a lambda value of minus 4 and a value of mu which is equal to -5. Hence, OX, the position vector of X, is equal to 4 minus 3, 2, minus 4, this is the value of lambda, 3 minus 2 minus 1, and this is equal to -8, 5, 6, which is the position vector of X. For B, I will start by making a rough sketch. I know I have two lines that they intersect at point X. P is a point on L1 and Q is a point on L2 such that PQ is perpendicular to line 2. I am given the coordinates of point P, so OP, the position vector of P, is 10, -7, 0. And I am also given that Q lies on L2, so OQ is of the form 2 plus 2 mu minus mu minus 9 minus 3 mu. So I can calculate PQ, which is equal to OQ minus OP. So this is equal to -8 plus 2 mu, 7 minus mu, and -9 minus 3 mu. I will use the fact that the dot product of two perpendicular vectors is 0. So PQ dot 2 minus 1 minus 3. This is the direction vector of line 2, and this is equal to 0. So -8 plus 2 mu, 7 minus mu, -9 minus 3 mu, dot 2 minus 1 minus 3 is equal to 0. So -16 plus 4 mu minus 7 plus mu plus 27 plus 9 mu is equal to 0. So mu is equal -2/7. So I can substitute this into OQ. This will give me 10/7, 2/7 minus 57/7. This is the position vector of OQ. Hence, the coordinates of Q are 10/7, 2/7 minus 57/7. In question 9, part A, I will use separation of variables to solve this differential equation. So a to the -3/2 dA, the integral of that, equals the integral of 1/5 t to the -2 dt. So -2 a to the -1/2 equals to -1/5 t to the -1 plus c. I'm going to multiply both sides by -1/2 or divide by -2, it's the same thing. So 1/square root of a is equal to 1/10t plus c. Note that the sign of c does not change because that does not matter. C is just a constant. So when t is 3, a is 2.25, which means 1/square root of 2.25 is equal to 1/10 times 3 plus my constant. C comes out to be 19 over 30. So my equation is 1 over square root of A equals 1 over 10t plus 19 over 30. I'm gonna write this as a single fraction. 1 over square root of A equals 2, 3 plus 19t over 30t. I can flip this, so square root of A equals 2, 30t over 3 plus 19t. So A is equal to 30t over 3 plus 19t, everything squared as required. Now for part B, I will divide everything inside the bracket by t. So I'm going to get 30 over 3 over t plus 19, everything squared. I'm going to make a note, divide numerator and denominator by t. So as t goes to infinity, 3 over t goes to 0, hence A goes to 30 over 19 squared, which is equal to 900 over 361.